So I told him, I said, yeah, it is just so bent. And she said, I'm going to start using that. And I'm like, you've never heard that before? It was an old 80s thing, you know. It was he is just bent. I mean, he's really twisted. It's like he's damaged.
Oh.
It was a slang term for somebody who was kind of sketchy. Bent. He's all bent, man. You want to stay away from that dude. He's bent.
I love how it's always a dude, not a girl. She's bent.
All right. So we understand it's actually also called angular.
I like bent.
Angular bent or bent angular? Or
No,
just
bent
Or angular.
or angular.
I like bent.
Which way would you prefer to call it? I like bent.
Bent for sure.
But when you get to college, you might have a professor who prefers angular. All right. So what happens with two pair? What happens when you've got two unshared pairs sitting up on top? Boom. Boom. So they really sit squatty on here. So they really push down hard on these bonds, repelling. And in order of repulsion, okay, these repulse each other more strongly than the unshared pair repulses the bond, which is a greater repulsion than the bond against bond. So highest repulsion, second highest repulsion, and least repulsion. And so that's why this one really, I don't want to break it, but they really stand up tall. By how much?
5 degrees more.
So 2.5 degrees every time you add one of these. So now we're down to a bond angle of 104.5. How are you doing?
So it goes down 2.5 for every unshared pair.
Yeah, and it depends on the arrangement, but on a tetrahedral molecule, yes.
I use my noggin on that one.
Now, the thing that you're supposed to really kind of see here from these is that they are all tetrahedral electronic. But then we've got tetrahedral molecular versus pyramidal versus bent in the molecular. Like it?
Love it.
Love it? Love it? Do BeCl2, beryllium dichloride. Beryllium dichloride. How many total electrons?
16.
Oh, you don't do.
Stop and count. 8, 16, 16. I've used them all. What's the last thing I do? Is the central atom happy?
No. No. Yes.
Yeah, because
Yes.
Beryllium.
Sorry, it took me a second.
Beryllium is happy with 4.
Sorry.
We're done.
Okay.
What's its generic?
82.
AB2. How many regions?
2.
2. What's its hybridization?
SP.
Perfect.
Go zone.
Perfect. SP hybridization. 2 bonds, 0 unshared pair. What does it look like?
Linear.
Hurtling through space. About 500 miles an hour. So, well, it would be. So a region of negativity, a region of negativity. They get as far away from each other as they possibly can. Oh, wait, how about 180 degrees? Is that as far away as they can get? Yeah? What do you think the shape is? Linear. Linear, Linear.
For molecular or electronic?
Well, you tell me.
Both.
Both, because why?
They have the same number of unshared pairs.
There are no unshared pairs, so they are the same. Bingo! Look at you go. All right, now do boron
So
trifluoride.
the bond angle is 180.
Yeah. Boron trifluoride.
I don't know why I tried a C.
Boron trifluoride. How many electrons?
24.
24. Central, bonded. Build octets. Stop, count, compare. 8, 16, 24, 24. Woohoo, I'm done. Oh, central atom. Is it happy?
Yes.
Boron is happy with 6. What's its generic?
That for real.
AB3.
Radiance.
How many regions?
3.
Hybridization?
SP2.
SP2. Perfect. 3 bonds, 0 unshared pairs. What does it look like? Mercedes-Benz. I had never thought of that. Well, what's bond angle?
What?
Bond angle?
No. That was a joke. 120. Yeah, 120.
120. This is a circle, is it not? Because it's all in one plane?
Radiant of like 5, 6 pi.
Now you understand. I told you the very first day of school, you were going to use everything you'd ever learned in this class, even geometry.
I didn't like it.
Well, but it's more fun now, isn't it? Because you got little toys to play with. All right. No. So
There we go.
AB3, it's all in one plane, but it's a triangle, isn't it?
I thought you said it was a circle.
Well, the angles are. When you do the angles, you think about it being spherical and
There's a circle and a triangle at the same time.
it is. Oh my gosh, depends on how you connect the dots.
Okay.
Do you connect the dots with an arc or do you connect them with a straight line?
I wanted.
Well, both ways. All right. So this one is called trigonal, trigonal, and then you add the word planar, Planar, planar. Not, we say planar, but planar is how you spell it. So trigonal planar, all in one plane, and a triangle. Like it?
It's the same for both because they don't have any.
Correct. They are both because they have none. All right. How are you doing?
I did it. Oh, there's a back.
Oh, and then there's a back and a second page and a third page. We're going to do this till you drop.
Oh, great.
All right, get out that one homework where you had the boxes.
Oh, no. I can't.
And what was the first one?
Carbon tetrabromide.
Oh, everybody knows what that looks like. All right, now you can tell me, and I'm not going to fill in all the dots around these. They have dots. Regions of negativity, hybridization, shape. There you go. 4 regions, SP3, tetrahedral. Done. How easy is this? What's the next one?
We write it down.
No. We're just going over this homework paper. Sulfate, you drew this. You put dots. I'm not putting dots. Right? 4 regions, SP3, tetrahedral. It's boring. What's next?
Hydrogen sulfide.
All right, now most of you probably did this. What is sulfur under on the periodic table?
It's under oxygen.
Oh.
Oh, so would it not look more like water? That would be a better way to draw.
Wait, why?
Are we grading this or are we
No.
fixing it? Okay.
Fixing it.
Wait, why are we?
It looks just like water.
But so anything in oxygen's group has the same.
Oh,
Yeah.
families of elements behave the same. Oxygen looks like that with hydrogens. Sulfur looks like that with hydrogens. Selenium, tellurium, they all look the same. All right, what's next?
Chlorine trifluoride.
Tri?
Tri.
It makes it so much easier.
So chlorine trifluoride. I'll teach you next time why you will not draw it this way in the future, and you fill the dots. And when you fill the dots, you've got 24, but you had 28 total to start with. So you're gonna have 2 pair on the central atom. Now I had people in tutorials coming in, and when they had these extra dots, they were doing this. Now why would I not do that?
It's on the
It's
Two
bar.
regions of negativity.
2 regions of negativity are not gonna hang out together. Alright? They're not gonna hang out together. What's the generic?
AB3U2.
AB3U2, 5 regions. Hybridization,
SP3D.
SP3D. How easy is this? What's the next one?
Nitrite. Trait. Sorry.
Alright, nitrate, ion. I think we've done this one a couple of times. Right? And it does resonate.
Really?
Did we have to draw that too?
You're supposed to. On the test, you will be expected to. Alright, now there's one that you had on another homework paper that I want to go over. NO2. It is not an ion.
Oh, it's not.
And it had 17 electrons when you added it up.
Oh, yeah.
Oh, yeah. Central atom. Bond it.
This was the
Fill them. Stop and count. 8, 16. 1 electron left. Ooh. Electrons like to be in pairs. Even so, it's only got 2, 4, 5 around here. I can make it a little happier by doing that. Now it's got 7. But you have to understand that this is not very stable. Okay? When you end up with 1 lone electron like that, you can't put 9. There's no way to fit 9 electrons in 4 orbitals. So, in nitrogen's period 2, it can't do expanded valence. So, when you do this, these compounds tend to dimerize. They form dimers. And so what's going to happen is that you will get a second NO2 molecule, and they will bond here. So you form a single bond between those 2 nitrogens, and it becomes N2O4. So NO2 is not very stable, and it tends to form N2O4. Yes, ma'am.
So you wouldn't simplify the subscripts, it'd just be N2O4?
Correct, because it's molecular. We don't simplify C4H10. Molecular compounds we don't simplify.
So on the homework.
Dinitrogen tetroxide.
Do you draw it like that on the homework?
No, you would do that one.
You just do the top with the
Yeah.
And when it says like unshaped radial electrons, you just put half.
How was it? Have fun in it. It's not hard.
Even with the last
think it